All right, today we're going to be looking at the first step to factoring polynomials. And this is something that can happen only on its own, but also a lot of times it's something that has to happen before we do the rest of the factoring that we're going to be learning in the next few days. So the easiest way or the beginning way to learn how to factor is by using what we call the greatest common factor. This is something that you did back in 6th grade. Obviously now we're going to apply it in a different way using variables, numbers, and exponents, but the process or the concept remains the same. But in order to look at factoring, we kind of have to also look at how the distributive property works to make the polynomial in the first place. So if we're looking at it, here we've got negative 4y squared times 5y to the fourth minus 3y squared plus 2. So again, as a reminder, using the distributive property, we would multiply that negative 4y squared into all three terms. A negative 4 times 5 is a negative 20, and then y squared times y to the fourth would be y to the sixth as we add those powers. Okay, and again, negative 4 times negative 3 is a positive 12, and then y squared times y squared is y to the fourth. And then lastly, 2 times a negative 4 is a negative 8, and then we keep the y squared. So that would be the distributive property. All right, going again to the second example. We've got 2x squared y times the polynomial 5x squared y squared plus 6x to the third minus 2x and plus y. So again, we would multiply to all four terms. It's kind of sneaky there at the end, but that negative 2x plus y, those are two separate terms. But that's what we've got to do here. So again, we're going to multiply numbers and then add exponents on like basis. So 2 times 5 is 10. X squared times x squared is x to the fourth. And then y times y squared is y to the third. All right, then we're going to multiply 2 times 6 and get 12. And then x squared times x to the third is x to the fifth. And then we write the y. All right, now we have it 2x squared y times a negative 2x, so 2 times 2 is a negative 4. X squared times x is x to the third, and then y. And then our last one, we have 2x squared y times y, so we would write 2. And then we would say x squared, and then y times y is y squared. All right, I want you to take a couple minutes to go through and do A, B, and C on the understanding check. And then if you want to, you can send a copy of that to your teacher for them to check. All right, now, the distributive property is how we make a larger polynomial, where greatest common factor is working backwards. It's pulling out that initial term that we saw in the first two examples that we did. So the common factor of a polynomial is the numbers and variables that are common to each term. So when I want to look at a number, or the largest number that I can take out of all the terms, and then going to the variable, I want the largest variable that I can take out of all of the terms. So if I look here, I've got 4x to the third, 12x squared, and 8x. Well, looking at 4, 8, and 12, the largest number that I could divide out of all three would be 4. 4 divided by 4 is 1, 12 divided by 4 is 3, and 8 divided by 4 is 2. All right, then I go to my x's. I've got x cubed, x squared, and x. And what really happens here is we want to look for a common variable, and then really it becomes to the lowest power because I can't take out more than I have. So our GCF here would simply be 4x. I can take a 4x or divide each piece by 4x and not break any rules by going to a negative exponent. All right, and then I'm going to do the first one of the understanding check and then let you do the second one. So I've got 5y to the fifth and 10y cubed. Well, the number they both have in common, I can divide both of them by 5. And then looking at y to the fifth and y to the third, the one I can take out is y, and then to the lowest power is 3. So I can take out 5y to the third out of both of them. All right, I want you to go ahead and take on the second one, the 4b to the third, 2b squared minus 6b. Go ahead and pause the video and try that now. All right, welcome back. Hopefully you saw that the number in common was 2 and that the greatest power that we could use is just b, or b to the first power. So 2b was the greatest common factor. All right, now we have a GCF. Our job after that is to factor a polynomial. Okay, and to factor a polynomial, we're going to reverse the distributive property, or work backwards. Okay, factoring completely means that we're going to be factoring out the greatest common factor. Okay, so I'm going to do the first two examples and then let you have some time and space to do the next two. So if I look, I've got 18, 12, and 24, and I want to think of the largest number that I can divide out of 18, 12, and 24. Well, I know I can divide them all by 2, I could divide them all by 3, and I could divide them all by 6, but I can't go any larger than that. So my first common factor would be 6. All right, now I'm looking at my variables. All three of them have an x, so I know I can take out an x, and then the lowest power would be x to the third power. Now, what I found the easiest way personally to get my final answer is I'm going to divide each piece by 6x to the third. And that's the easiest way I found to really look at it and kind of see what happens. So 18 divided by 6 would be 3. X to the fifth divided by x to the third would become x squared because there are 2 more on top. Okay, and then a negative 12 divided by 6 is a negative 2. And then I have x to the fourth divided by x to the third. There is 1 more x on top. And then lastly, 24 divided by 6 is 4. And then x to the third cancels out x to the third. So this is what remains after I have taken out 6x to the third. So this would be my final answer right here. After taking out the greatest common factor, these are the two factors that I have. All right, looking at number 2, I've got 32, 48, and 60. I know that I can take out a 2. I know that I can take out a 4. But I can't take out a 6 out of all of them, and I can't take out an 8 out of all of them. So it looks like 4 is the largest number that I can remove. So I write my 4. Now I look at my variables. I've got an x squared and x, but the last term doesn't have an x. So I cannot factor out an x. So the only thing I can do is divide all of them by 4. So 32 divided by 4 is 8x squared. 48 divided by 4 is 12x. And then 60 divided by 4 is 15. So in this case, the only common factor was 4. All right, I'm going to go ahead and let you pause the video and take a try at examples 3 and 4. Okay, welcome back. Hopefully when you looked at number 3, you noticed that you could take out a 2 and an x squared. So 4 divided by 2 is 2, and then x to the third divided by x squared is x. And then 6 divided by 2 is 3. And then x squared divided by x squared cancels out. So your answer on number 3 should be 2x squared times the parentheses set of 2x plus 3. All right, and then on number 4. Looking at that, we've got 24 and 18. A common number with 24 and 18 would be 6. M N, that's my common factor, or my greatest common factor. And then what would remain would be 24 divided by 6 is 4. M squared divided by M is M. N squared divided by N is N. And then negative 18 divided by 6 is negative 3. And then my M and N get canceled out. So that would be the answer for number 4. All right, if you want to, you can finish up by practicing the 6 on the bottom, making sure you understand how those work. If you have any questions, please let your teacher know.